Welcome back, everybody. Today we're going to talk about quadratic equations. Now, the main thrust of this section is going to be to graph quadratic equations. So we're going to graph, graph in standard form, from standard form of the equation. And we'll also graph from general form of the equation. All right. We'll also do some application problems, and we'll work on the quadratic formula. All right. So the first thing we need to start with is, what is a quadratic function? A quadratic function is any function where x squared is part of your leading term. So, for example, the general form of our equation is y equals, a, b, and c are always our coefficients, ax squared plus bx plus c. This is general form. And now we're going to show you standard form. This is also called vertex form, and I'll tell you why in a little bit. But that would be y equals a times x minus h, the whole thing squared, plus k. Both are quadratic equations. Both tell you an awful lot about how to graph. They just tell you it in slightly different ways. So we're going to start with general form. Okay? So, hang on. There we go. Let's start with general form. So that's y equals ax squared plus bx plus c. All right. So first thing to know is that if a is positive, parabola opens up. And the parabola is the shape the graph makes. The parabola looks like a U, and it is the general shape of any quadratic function. Could be shifted left, shifted right, reflected, fat or thinner, but they all look like parabolas. So if a is negative, the parabola opens down. And that is something more to check to make sure that your graph is good. All right. The next is your vertex. All right. So remember how this is our, right, our form of the equation, most general that we could make it, right, with a's, b's, and c's. So your vertex is negative, not negative a, just kidding about that, negative b over 2a, and the y coordinate is you take that number and you plug it into your function like that. So there's your vertex, and we'll talk about making the vertex when we hit an example. All right, the next is your axis of symmetry. So number 3 would be axis of symmetry. All right, and that's x equals negative b over 2a. And this is for parabolas that open up or down. When they open left or right, it'll be different. But for purposes of this section of this class at the moment, right, our axis of symmetry will be x equals, because it will be a vertical line. All right, and the last thing we need to know before we start an example is we are going to make a table of values. Now, people always have trouble making this table of values, and I'm going to give you a hint as to how to make a better one. If you know your vertex, put that right in the center of your table of values. And then just get 1 or 2 points to the left, 1 or 2 points to the right of your vertex, and you will always get that U shape. The key is you need a good sketch of your graph, right? And rather than just guessing at the table or having 5 standard X values that you're going to plug in, like I said, put your vertex in the center, get 2 values to the left, 2 values to the right, and you should be fine. All right, and that way you can account for any shifts that happen in your parabola. Let's try an example. So your example is y equals 2x squared minus 8x plus 6. All right, so let's go through the things that we know. A is 2, and 2 is positive. So the first thing we know is the parabola opens up. That's good to know. Mostly that if we graph it and the parabola winds up opening down, then we know there's a problem and we have to recheck some things. All right, the second is your vertex. All right, so the x coordinate equals negative b over 2a. And in this case, b equals negative 8 and a equals 2. All right. So why don't you pause the video, do the calculation, and tell me what x is. All right, so hopefully you plugged in. So I get x equals, I have negative 8 over 2 times 2, which is 8 over 4, which equals 2. Now we take that 2, and if you plug it into the original equation for x, you'll get out your y value. So why don't you do that? Why don't you pause the video? I'm going to write it out. Pause the video, do the calculation, and let's check our answer on the back end. All right, so if you did the calculation, I got negative 2. So we could say the vertex is 2 comma negative 2. All right. Now our third step is to get our table of values. All right. And if we're going to get our table of values, all right, that's basically what our table is going to look like. We put our vertex in the center, and then we flank it with 2 extra points each. So why don't you do this? Why don't you fill in the table, and again, we'll check our answers. All right, so hopefully you paused the video, and you took your x values and ran them through the original equation. I got 6 here, 0 here, 0 here, and 6 here. So now all you have to do is plot the points and connect the dots, which is really great. All right, so your last step, 1, 2, 1, 2, there's your vertex, and then 0, 0. And then you come down. do the best you can. I am not the greatest drawer. So, but you notice that I have all the appropriate work to show all of my points. All right. It is a more direct way of doing it rather than just a matter of guessing and checking. All right. So here's another type of problem we could do. This one's a little bit quicker. All right. Without graphing, locate the vertex, the axis, and the axis of symmetry. Does the parabola... Drop my stylus. Does the parabola open up or down? All right, and here it is. It's f of x equals 2x squared minus 3x plus 2. All right, so why don't you pause the video and find that vertex? All right, and we'll come back and we'll check our answer on the back end. Give it a shot on your own. All right, hopefully you took a shot. Negative b over 2a. So again, we have negative 3 over 2 times 2, which is 3/4. And your vertex most definitely can be, not be on a grid point, especially one that's easy to estimate. So again, you just estimate. I'm not going to, no teacher is going to sit there with a ruler measuring to make sure you're exactly 3/4. You just got to make sure that you're greater than a half, but less than a whole, somewhere around the middle, of the half and the next point. For the y value, you do f of 3/4, and I got that to be 7/8. So this one is the more difficult calculation. So if you did not get 7/8, go back and check. All right. So your vertex is 3/4, comma 7/8. Again, when you have fractions, you are going to estimate. So this is your first question that you're answering. Your second one is the axis of symmetry. And your axis of symmetry is going to come from the x value of your vertex. So it's going to be x equals 3/4. That is going to be a vertical line going straight through your parabola, cutting it right in half. And because 2 is positive, we know our third question is that it opens up. So slightly shorter question because it did say without graphing, right? Once it says without graphing, it's going to be a little bit shorter, but it still encompasses all of the techniques that we did. So let's take a look at the next form. This is called standard form. Back in the day, back when I was sitting in your chair, it was called vertex form. And there it is. Now, A is the same, meaning that if A is, I got to put A in. There's A. I'll make it better. I can make that better. Y equals A times X minus H. There we go. If A is positive, the parabola opens up. if A is negative, the parabola opens down. So A doesn't change from one form to the next. However, your vertex is a whole lot easier to find because your vertex is h comma k. All right, and your axis of symmetry, I'm going to use AOS for axis of symmetry, is x equals, and again, we get it from the x coordinate of our vertex, x equals h. All right, now the good part is that our table of values can be made the exact same way. Right, and right in the center of our table can be our vertex h comma k. You get 2 points to the left, 2 points to the right, and you can make a nice parabola. All right, so let's try one. Let's see how it goes. All right, so graph the function. Y equals negative 1/2 x plus 3 squared plus 4. All right. So in order to do, let's run through our steps, right? Step 1, we take a look at A to see if it opens up or down. In this case, A equals negative 1/2, so it opens down. And this again is just to make sure that we are going in the right direction. When we graph, we already know that it should open down. Now, the second thing is a little bit tricky. We need our vertex. And that is h comma k. Now, here's the thing. In our standard, right, in our form, it was x minus h, right? But in our example, in the parentheses, it's x plus 3. Can I make it look like the first one? I sure can. I can take my parenthesis and make it x minus negative 3 squared, okay? So if I do this, then my h is right here is negative 3. All right, so my vertex is going to be negative 3 comma, there's my k, 4. All right. My third step is to do a table of values. All right. So we get x, y, negative 3, 4. So I get, negative 2, negative 1, negative 4, negative 5. So why don't you at this point pause the video. I'd love for you to run through your table of values. I'm going to try to get your equation in there. And we'll talk about what the answers are on the back end. All right, so hopefully you took the time to run these numbers through your equation. I got 2, 3.5, 3.5, and 2. And now it's a matter of graphing. So let's take a look at a graph. Let's see. So I got 1, 2, 3, 4. 1, 2, 3. My vertex is at negative 3, 4. Negative 2, 3.5. Negative 1, 2. I kind of jacked up my drawing a little bit, but not bad. If I was making this for a grade, I probably would redo the drawing. You know what? Let's redo the drawing anyway. What the heck? This is the last thing we're doing anyway. May as well move it over just a little bit. Okay. So I got -3, 1, 2, 3, 4. -2, 3.5. -1, 2. -4, 3.5. 5, 2. So I go up and down. Not my best work, but it's still mathematically accurate. As long as I have the work to support my data, this would yield me points. All right, so that is the end of part 1 of quadratic functions. Part 2, we will take a look at the quadratic formula and some applications. All right, thanks for listening, and I'll see you guys next time.